Hi, and welcome to the lecture for January 23rd, 2014 for CISD 1400 Intro to Computer Programming. Today we're going to talk about arithmetic, booleans, and we'll do a quick intro to if statements. In order to fully make sense of this lecture, you probably should have read sections 2.5 through 2.8 and maybe section 2.10 of the Title to Text Intro to Java Programming Late Objects Edition. Though, of course, if you choose to read the text after that, this will also be okay. So today, we're going to talk about arithmetic and operators, specifically with integers. We'll talk about operator precedence, which is sort of like the order of operations you learned in elementary or middle school. We'll talk about booleans, which are a new data type. We'll talk about the relational and equality operators, which is some math that we can do in order to get booleans. And then from that, we'll introduce if statements, which will let us do some decision making. So all in all, it should be pretty okay. Let's look real fast at, before we start too much, let's look real fast at the data types. So far, we've talked about, in terms of variables, we've talked about integers, which we abbreviate to int, int. We've talked about strings, which are just text. Integers are numbers, strings are text. Strings start with a capital S. And we've talked about scanners, which we use to get input. Now there are two different types of variables. We have primitive types, and we have reference types. Primitive types, like integers, are just containers for information. Right? It's just a spot in memory that has a specific size and that holds a specific type of data. Reference types point to objects, like strings and scanners. We're not going to worry about those very much today. Today we're only going to worry about the primitive types. Now there are 8 primitive types. And so the primitives are broken up into 3 categories. We have our numerics, our characters, and our booleans. And so far we haven't talked about characters or booleans, so we'll get to booleans a little bit later today. And of the numerics, we have floating point types and we have integer types. And so far, all that we've talked about is the integer type int, which is a 32-bit signed integer. It goes from negative 2 to the 31st to positive 2 to the 31st minus 1. A little bit less than 2 billion, and a little bit less than negative 2 billion, and a little bit more than positive 2 billion. And we'll talk later, and by later I mean in a couple of weeks, about the floating point types and also about some of the other primitive types. We'll also talk in a couple of weeks about characters, and we'll talk here in a couple of minutes about booleans. Now we can modify and arrive at the values of numeric types by way of arithmetic operators. And these operators work differently depending on if we're working with integer or floating point types. Now with the integer types, the one that we're going to worry about right now is the int. That's the default. That's what Java assumes everything is. The floating point types are floats and doubles. Doubles are the default there, and we're not going to worry about those for a couple of weeks. Now the integer types, like the int, these are whole numbers, both positive and negative. And when we do math with integer types, we always get an integer result, even if we're doing division. So that is to say that we never get a fraction or a decimal. So if we're doing integer math with Java, and we do something like 8 divided by 3, the answer that we're going to get is 2, rather than 2 2/3 or 2.6 repeating. And the reason for this is that when we're working with integers, the fractional part of whatever the result of our operation is gets lost. Or more specifically, it never gets calculated to begin with. We don't ever have that. With the floating point types, like the float and the double, we get a floating point number, which is just a regular number, except it has a decimal point. And that decimal point floats using scientific notation. So if we do 8 divided by 3 doing floating point math, we'll get a 2.6 repeating, or more specifically, we get 2 followed by 13 sixes followed by a 7. As we're accurate out to 15 decimal places, or out to 15 significant digits. And we'll talk in a couple of weeks about floating point math. For right now, we're only going to worry about integers. Now with the arithmetic operators, most of these are going to look pretty familiar to you, and we use these guys to do math. We'll start with the assignment operator, which is just an equals sign. It's a single equals sign. This becomes important later. It takes whatever is on the left side and assigns it or puts it into the variable or whatever's on the right side, and assigns it or puts it into whatever's on the left. So with this very first one, x is equal to 3 plus 8, that's going to work. We're going to evaluate and resolve the 3 plus 8 to get 11, and then we take that 11 and we put that value into x, and that works just fine. Now the other one, this 8 is equal to x plus 4, this might look familiar in that it's the type of problem that you would have seen in your first algebra course. And it's pretty easy to solve for us humans, but Java is going to throw a fit, because what Java thinks we're trying to do is take x plus 4, where x is going to be some value that we already have, and assign that to 8. That is to say that Java thinks that we're changing the value of 8. That isn't going to work. When we're using assignment, we have to make sure that whatever is on the left side of our equals sign is a variable, and whatever is on our right side is some value that resolves to a type that can be assigned to that variable, in this case a number. The asterisk, the forward slash, and the percentage sign are all collectively known as multiplicative operators. The asterisk multiplies the values to the left and right together, and then whatever that result is, that's a single number. So with x equals 8 times 3, we first multiply the 8 and the 3 together to get 24, and then we assign 24 to x. So it's a two-step process. The forward slash divides the left value by the right and only keeps the whole number portion. We drop whatever fraction might exist. It doesn't even exist, and it never exists. So if we do something like x is equal to 7 divided by 3, we know that this is 2 and 1/3, but in Java, because both of these are integers, we get an integer result, which is to say that 7 divided by 3 ends up being 2, which we then assign to the value of x. And so remember, with integer math, if you have integers coming in, you get integers out. The percentage sign is one that you probably haven't seen before, and we call this one modular division, or the modulus operator. And what this one does is it divides the left number by the right number, and then discards and then keeps only the remainder. So if we do something like 17 mod 3, our result is going to end up being 2. So 17 divided by 3, if we do this by hand, is going to be 5 with a remainder of 2. We get rid of the 5, we keep the remainder. The modulus operator, and this is going to become apparent here in a bit, is particularly useful in computer programming. Some initial uses that we're going to see today are going to be doing things like checking divisibility. If a number divides evenly, it'll have a remainder of 0. So that's a quick way that we can tell if a number is a multiple of another number. A couple of other things that we might see are using the modulus operator for cryptography. You might have heard of RSA cryptography, which is based on using very, very large prime numbers, like prime numbers with hundreds and hundreds of digits, and looking at the remainder when you multiply or divide a number by those prime numbers. So it ends up being usually pretty secure, though it's becoming progressively less so as computers become more and more powerful. The arithmetic operators, addition and subtraction, are going to be pretty familiar to you. The plus sign adds two numbers together. The minus sign subtracts the number on the right from the number on the left. That's going to be pretty familiar. The parentheses works in Java exactly like it does in algebra, which is to say that when you have parentheses, it indicates that the expression in parentheses needs to be evaluated first. Now sometimes you're going to have parentheses inside of parentheses, in which case you start with the innermost set and you work your way out. Now this is a lot of operators, and they mostly, when we're evaluating everything, follow rules of the order of operations that you learned in your algebra class. But there are a couple of differences. There are a couple of very, very crucial differences that we need to know. First is that anything in parentheses gets evaluated first, and we do that from left to right. The second thing is that multiplication and division, that is to say multiplication, division, and modular division, they get evaluated left to right, which is to say that it isn't like what you may have learned with your please excuse my dear Aunt Sally order of operations, when you probably were taught to do multiplication first and then division. By what Java does, it goes from left to right. It does not discriminate between these three operators. Now after all of the multiplication and division is done, we do our addition and subtraction, that plus and minus, we also do that from left to right. Then finally, when all of our math is done, we do an assignment, if there is one. And that goes from right to left. That is to say, we take the thing on the right and we put it into the thing on the left. And later we'll talk about doing things like compound assignment, but that's not terribly important right now. Now the best way to practice arithmetic, and especially the integer arithmetic, because that's what we're going to spend most of our time on in this course, is to write the math into a Java program, then generate answers by hand, and then check them against Java's answers. Now Java's answers are always going to be correct. Now whether or not Java's answers are the thing that you intend is a completely different matter. But the Java compiler, the Java virtual machine, will always evaluate the math correctly. That is to say, it will always perform the operations exactly as they're written. And so with that, there are a couple of best practices that we can adopt. Thing one is to make sure that we're using parentheses to control the order of operations. Thing two is if we have a complicated multi-step operation, it's totally okay for us to break that into smaller steps. It's totally okay. If you want to compute, say, the numerator of a complex fraction, and then the denominator of a complex fraction, and then do the actual division, that's okay. That's totally legit. The third thing that we can do, and this is a readability thing, and I'll show you in a second, is to make sure that we're being really careful about how we use our spaces to maximize readability. And the last thing is, this is sort of an algebra thing, this is an arithmetic thing that we can do on our part, is anytime we know that we're going to program a complicated expression into Java, we can do ourselves a favor by simplifying that expression as much as possible before we write it into the program. Particularly if you're looking at some of the calculus expressions that you might use if you're doing any of the heavier duty processing. If we can turn those into, say, Taylor series beforehand, that will often make our lives easier and speed up. It'll make our lives easier, it'll make the expressions easier to modify and to maintain, and it will also, in a lot of cases, make Java run faster. When we come back, we're going to take a look, we're going to open up Vim and do a little bit of experimentation with our math. I'll see you here in just a few seconds. Bye.